welcome to our channel. In this session we are going to discuss about data flow analysis. The data flow analysis is a technique of finding how the data flows through a program. Okay, that is, it identifies how my data is flows through the program. The main thing is it involves tracking of variables, tracking of the values of the variables and the expressions that are evaluated during the program. Simply, it tracks the values of the variables and the expressions that are evaluated during the program. Why it tracks all these information? The main goal for tracking all these information is identify the opportunities of optimization and identification of errors. If you track the program, then you can easily identify the possible places of optimization, and it is possible to identify the errors that are present in the program. That is the reason we analyze the flow of data to the program. Generally, in the data flow analysis, our program is modeled as a graph. So, data flow analysis, my program is modeled as a graph. Within the graph, the nodes represents the statements, that is the instructions of the code. The nodes represents the statements of the program, and the edges specifies the dependencies between the nodes. That means the dependency from one statement to another statement are represented by using edges. So if it is a graph format with nodes and flow of data through edges, it is very easy to analyze the flow. Clear the point? This is the basic definition of data flow analysis. And what are the main advantages? So why we are using this one? The main advantage is of better quality, code quality improvement. Yes or no? Improving the quality of the code. Why? If you are track the data, we are doing optimization. Where optimization is necessary, we are doing optimization. Obviously, the code executes very fast and takes less space. So, automatically the quality of code is improved. Next one, better understanding or better identification of errors. Yes or no? Again the same reason. If you track the program, in the sense, if any error occurred, it is very easy to identify the error. Why? We are following step by step. We are flowing all the possible path. It is very easy to identify the errors. And the next one is understand behavior of the program. Understand behavior of the program. Why? We are represented in a graph format. If we are represented in the graph format, we understand the flow of data. That is, if you are following through the edges, what is the program, what are the operation that the program do, what is the output of the program, it is very easy to understand if you analyze step by step. So these are the main advantages for performing the data flow analysis, for doing data flow analysis. Okay, now before going to the properties of data flow analysis, first you need to know some basic definitions. The basic definitions are, we have 3 points: definition point, reference point, and evaluation point. So generally my graph consists of 3 types of points: definition point, reference point, evaluation point. Definition point is simply a point in the program where we are defining a variable. A point in the program where we are defining some variable. This is called definition. Yes or no? Assigning some value is called definition. Now this particular point is called definition point. Suppose some number of statements. Now reference point, a point in the program where we are referring some data. The point in the program where we are referring some data. See this one, b is equal to a. Now b also refers to the same variable a. B also refers to same variable a, and this is called reference point. The point in the program where it refers to some variable. It refers to some variable and some set of statements in between there. And evaluation point means the point in the program where we are evaluating some expression. The point in the program where we are evaluating some expression, that is called evaluation point. That is called evaluation point. Okay, these are the 3 points that are used in the data flow analysis. Now finally we are moving to the properties of data flow analysis. The properties of data flow analysis. First one, available expression. First one, available expression. Available expression means simply a point in the program. A point in the program where an expression is available. Point in the program where an expression is available means the value is already computed and we are reusing. A point in the program where an expression is available means that the expression is already available. That expression is already computed. Without any changes we are reusing. That is called available expression. I will give you one example. You will get the complete idea. For example, some L1 is equal to 4 into I. L1 is equal to 4 into I. Here some x is equal to y plus a of L1. Now here some k is equal to 4 into I. Assume this is block B1, block B2, block B3. Observe here the expression 4 into I is available for block B2. Why? Here we are using 4 into I. Now what is available expression? A point in the program. This is my point. A point in the program where the expression available means that expression is already computed. Yes or no? We are already computed and here we are reusing. Without any modification we are reusing. Now the expression 4 into I is available to block B2. At the same time, same expression is available to block B3. Available to block B2 and block B3. Observe this one. What is the use of this one? The purpose of this one is simply to identify the common sub-expression. Yes or no? What is the main aim of this analysis? To do optimization. So, For identification of these common sub-expressions, we are using this one. Observe this one. Here 4 into I is already computed. We are not doing any modifications between this statement to this statement. This is a common sub-expression. Simply you are writing k is equal to L1 means we are eliminating common sub-expression. Clear the point? This is called available expression. Okay. Now, second one is reachable definition. Reachable definition. So, reachable definition means simply a definition D. Definition means some x is equal to 5 like that. That is called definition. A definition D reaches to a point x. A definition D reaches to a point x if there is a path, from D to x. So here we are at somewhere we are defining one definition. From that definition to we are reaching some point x in the program, and if there is a path from that definition point to the point x, there is a path from D to x such that D is not killed. D is not killed means simply not redefined. D is not killed. That means from D to x, the definition D is not modified. That is called reachable definition. That is called reaching definition. I will give you one example. For example, x is equal to 5. Now, x is equal to x plus 2. Suppose y is equal to x plus 3. b1, b2, b3. Here we are defining one point. In between some statements are there. Observe, in between some statements are there. In all the statements, assume the value of x is not modified. Assume the value of x is not modified. So, for example, b1 to b2. This is called reachable definition. Here, whatever the definition of a variable, the definition is used here. This is called, this block B2 is the reachable definition, but not block B3. Why? If you are in B3, so the value of x is modified. So only B2 is the reaching definition for B1, but not B3. Why? So B1 to B3 in that path, B1 to B3 in that path, we are modifying the value of x. So this B1 to B3 is not a reaching definition. Clear the point? From the definition to some point in the program, in between the value of the variable is not modified. That particular is called reachable or reaching definition. Reaching definition. Okay. Live variable. Okay. Live variable means a point in the program where a variable is live, means that value or expression is used for future computation. That value or expression is used for future computation, and that point is called live variable. Or else simply, if a point is a live variable, a point P, assume a point is a live variable, from P to end of the variable, P to end of the variable, the value is used before it is redefined. P to end of the variable, the value is used before it is redefined. Otherwise, that is called dead code. So, I will give you one example. Suppose A is equal to 5, some C is equal to 6, B is equal to 7, D is equal to some A plus B, A is equal to for example C plus D. Block B1, B2, B3, B4, B5. Now observe this point carefully. Here the variable A is equal to 5. It is live at block B3. It is live at block B4. It is live at block B2 is okay, no problem. It is live at block B3 means we are using the variable in this path. We are using the variable before it is redefined. Here I am using A plus B, but the value of A is not modified. So the variable is live at block B1, B3 and B4 but not B5. Why? In B5 the value of A is changed. Clear the point? Whenever we are changed the value of A, that is called not a live variable. That is not a live variable. Live at B1, B3, B4 only. Why? Because in B5 the value of A is redefined. The value of A is redefined. Okay. Now the last one. Busy expression. Last one, busy expression. Now see this one. Busy expression means, for your understanding I written the complete definition. See this one. An expression is busy along a path. For example, this is one node, this is one node. Assume this is the path. So if an expression is busy along a path if its evaluation exists along that path. Expression means we are evaluating the expression. If an expression is busy along the path, if when the evaluation of the expression is also existed along the path, that is in that path we are evaluating the expression. In that path you are evaluating the expression with one condition. What is that one? None of its operand definition. So expression means it consists of multiple operands. None of the operand definition exists before its evaluation along that path. So expression consists of multiple multiple operands. None of the operand definition is existed. None of the operand definition is existed before the evaluation along the path. That means in that path only we are defining and evaluating the expressions. That is called busy expression. That is called busy expression. The main purpose is code movement. Here available expressions main is common sub-expression. Reaching definition, the purpose is copy propagation, either variable propagation or constant propagation. Live variable means identification of register allocation. Busy expression means the code movement identification. These are some of the properties of data flow analysis. Thank you.